Then press this. It comes with a force F here, and it gives you a shape, cup like shape it can give you from here. Similarly, you have tube drying, where you can have raw material here and you put a mandrel and push it through it. Pull it or push it through the raw material. Outer die is controlling the shape. Outer die is controlling the shape. If it is reducing, it is reducing because of the outer die here. Spinning is another operation, very common operation. Just see, this is the inside mandrel and this is the raw material, this is rotating, and you have external spinning tools which control the external shape of this. Now, internal shape will be controlled by the shape of the mandrel here, whereas external shape will be controlled by the outer tool, motion of the outer tool. We will see it again. Just see, this is the mandrel which will control the inner shape. This will control the inner shape, but outer shape will be controlled by this tool. So, this is the raw material red, and this is, as you go on, you go on pushing the mandrel into it, and there is a tool outside, it controls the outside shape, and the inside shape or the overall shape of the component will be this. This one, this finally you will get this shape. Then you have hydroforming, that means instead of I will explain this here, you have the part here, this is the part which is made, you have a plunger here, this is the raw material, and this is oil filled forming cavity, nothing to do. This is basically to control the initial shape, it is to keep the raw material into shape. So, then you apply pressure from below, just see the piston has moved up and it has given you the shape. This is the final part. Then explosive forming, just see, this is the die basically, this is the shape which we want here, this is white one, this is the shape which you want here, and this is the raw material green one, this is the raw material, this the red one is the clamps for holding the raw material, this is the detonator, explosive, right. So, when you explode it, the water pressure is generated and the metal part, this metal will take the shape of this die. Now, naturally, if you want to go beyond this, you have to have enough force that the clamps will not leave this material. They will keep it securely in hold, so that the material will not go off. If the material goes off with the pressure which is generated here, then you will not get the component. Similarly, just see, there is a explosive cartridge here, this is the raw material, maybe a tube here, and you want to make the shape of the tube like this here, from here. So, because here it is fully constrained, here the tube cannot expand like this, here the tube cannot expand like this, similarly it cannot expand like this, it cannot expand like this. The only space where it is here it is, there is a space here available where this tube can form in this direction, it can go into this direction. So, when you fire this, when you create pressure, generate pressure in this, nothing will happen here because this is constrained here. There is no space for this tube to go in this direction or in this direction, but it can always go in this direction, it can always expand here. So, you will get the desired shape here. So, these are some of the presses. This is hydraulic press, where you move the plunger or ram with the help of hydraulic fluid. This is a mechanical press, where you have eccentric shaft. So, it is like a crankshaft, and you move the upper half of the die or punch, what we call it as, in up and down directions. So, just see, this is another type, knuckle joint type press. This is a screw press, that means this will rotate and go down. These are more positive type of presses. Then this is a gravity drop hammer, that means just it will with the help of gravity it is moving down. This is a mechanical press here. If you see, this is a bolster plate here. This is basically the bed of the machine. Shut height is basically what we call it as the height between the lower half and upper half, that means die and punch when it is in the totally lowered position. So, this is the minimum gap which will always remain. You can have a hydraulic press also here. Hydraulic presses have that they can have longer strokes than mechanical. Forces can be higher, and the stroke motion is uniform, of uniform speed, because you are providing through a hydraulic media. Now, there are different types of dies which we use in metal forming or press working. Simple single operation with a single stroke, that means like we have a punching operation, blanking operation. Compound die, where you have you see, it is not always required, or it is not always advisable also, that you will have only one operation in one stroke. Depending upon the press capacity and the forces required for making that operation, we should always try to complete many number of operations in a single stroke to save the time, to save the tooling also. So, you have compound dies where two operations with a single stroke are done. Then you have combination dies where you can have a continuous type of operations, that means two operations at two stations, different stations, and you have progressive dies where you have two or more operations at two or more stations with each press stroke. I will just show you. Just see, this is basically a punch here, a pilot and a punch here. So, in a single stroke, what we can do is we can have two operations. I can have this as well as this hole. So, this is just some introduction to basic metal forming operations. If we sum up this, the metal forming is basically changing the shape of the raw material. You may be cutting the raw material, you may be bending the raw material, you may be giving some other shape. The basic processes, if you know, is we start from rolling, forging and sheet metal cutting. In addition, what we have is we have a casting process where you use the material in the molten metal form. The material is heated and melted, and it is put into a cavity which we call it as a mold. So, there we have a different liberty of making the shape. We are completely free to make what we want. In foundry, we make a large variety of components. If you see this in an automobile or in a two-wheeler or a four-wheeler, what you have is your cylinder is made by casting. Your cylinder head is made of casting, and there will be many components which will be made by forging also. So, what I will suggest is that when you go out of this lecture, just look at your bike, look at your car, and try to identify which are the components which have been made by casting or plastic molding or forging or sheet metal working, and what type of equipment must be needed for this? You should take a note of this, and why a particular type of technology has been used for making that component. So that is all. That finishes my time also. Thank you very much. If you have any questions, please do ask.